Hey, good morning, everybody. Thank you for joining us. We're going to give it just one more minute for everybody who's kind of signing up right now, and then we'll get going. Okay, once again, good morning, everybody. We really appreciate you joining us today. I'm here with Kevin Blackmore in our New Zealand office, and we're going to be talking about advanced greenhouse controls. So we've already talked to you about the basics, so what's next?
So just a little bit about us. So my co-presenter here is Kelly Nicholson. She's our sales director in Controlled Environment Agriculture. She's got a Bachelor of Arts in Communications. She's had 17 years in the hydroponics industry, from small home gardeners all the way up to large multi-acre farms. And she's done tons of on-site training, installations throughout the US, Canada, New Zealand, Australia, all over the place.
And a little bit about Kevin. So Kevin has a Master's of Engineering Studies from Auckland University. He is based out of our home office in Auckland, New Zealand. He's at 18 years with Autogrow, of course, beating by one. He has been a design engineer, the R&D manager, the product manager, and he was the lead designer of our popular IntelliDose and IntelliClimate line, as well as our multi-grow product lines. So who is Autogrow? So Autogrow was established in 1994. We're committed to creating and providing the most amazing solutions we can come up with to solve the world's most difficult problems in producing crops. We believe growers should have affordable, accessible, and easy-to-use innovation 24/7 anywhere in the world.
Our global headquarters is in Auckland, New Zealand, and we've got growers and resellers in over 37 countries. We provide, intelligent hardware, software, data solutions for single compartment environments, all the way through to large-scale, fully automatic greenhouses and warehouses. Our team of software engineers, horticultural experts, data engineers will continue to push the innovation boundaries to try and gain the best results for you guys, the growers.
So let's start. Let's get going on advanced greenhouse controls. What is it that we should be considering? So we're just going to do a quick recap. So last time when we talked to all of you, it was October, and we did an introduction to greenhouse controls. And so we talked a lot about managing temperature and humidity, why it was important. Of course, one of the biggest things is that managing your temperature and your humidity properly will help you to control pests and disease, which can be create tons of crop loss.
And the other aspect is to ensure proper plant growth. So by maintaining a really good temperature and humidity climate for the plants, you can steer them in a particular direction from a vegetative to a generative stage, and we can promote the transpiration rate, giving you much better quality crops at consistently quality with a larger yield. And during that presentation, we talked about what sort of basic controls that you can do to manage those things. So from operating vents, which could be extraction fans, extraction fans, air circulation fans, vents to try and cool the greenhouse and purge that wet air out, wet walls if you're in a more arid climate, and all the way through to heaters and energy curtains to try and control the heating and reduce the volume of air that you're managing.
So today we're going to just take it to the next level, and we're going to talk about advanced controls. So to create the perfect growing environment, you need to manage more advanced aspects than just, exchanging, air in a greenhouse by using fans. So to get the best crop, you need to have the most advanced controls. And so some of the things that we're going to talk about today, we're going to touch on vapor pressure deficit. So we're going to talk about VPD and how that works into advanced control systems, as well as CO2 in greenhouses. We're going to talk supplemental lighting, blackout curtains. We're going to touch on root zone management today too. So what type of growers should be using advanced controls?
So what we find is that a lot of growers have relatively simple greenhouses. So it may be a tunnel house, could be a house with a mesh wall or something like that, and so they have no need for advanced control. But similarly, they may not have the proper equipment to do that advanced control. If you don't have a vent that you can open, and you've got mesh walls, you can't contain the environment and provide the ability to control it.
Yeah, and so when a grower is considering adding in these type of advanced controls that we're going to be discussing, one of the big things that the first question is, how much is it going to cost me? What is going to be the increase to my overhead? So you have to look at that initial installation expense, and then you need to look at the crop that you're growing and determine if you were able to increase the yields that you were getting, or increase the amount of times that you were able to harvest. Would you be able to sustain that increasing cost? And so that's really up to the grower to determine what crop they want to grow and if these additional costs will make sense. Some of the types of specialized greenhouse control that people look at, CO2. So CO2 in greenhouses, you get kind of mixed reactions when you talk to people about it. Some people think it's a waste and it doesn't actually have any effect. Other growers will tell you that they would never grow without using supplemental CO2 in greenhouses. So we're going to get into that a bit. And then lighting. Obviously, lighting is a huge expense. It's one of the most expensive parts of the equipment that you put into your greenhouse, and the energy expense of lighting can be huge. So you really want to have that very controlled to make sure that it's the most efficient it can be. And also using blackout curtains to steer plants into different growing stages. So we're going to dive into all of those a bit more.
So the first thing we want to talk about is vapor pressure deficit, or VPD. This is a really popular measurement that gives you an idea of the ability of the crops to transpire. So what is VPD? VPD is the measurement of the evaporation potential of the air. So essentially, it's telling us how able will the plants be to transpire, get that vapor off of them. So it can be used as a good indicator of crop stress. It's not a direct measure of crop stress, but it does give us a good indicator about how stressed the crops may be. So what types of things can we do? What types of things can happen with the VPD? So if the VPD is low, what we'll find is usually what will happen is because of the high humidity, or it could be a low temperature. And what will happen is the plants will have stopped transpiring, their stomata will be wide open, exposing a little pool of water, but there'll be no evaporation, which means it's an excellent haven for fungal spores and disease and what have you. And there could even be mineral deficiencies in the plants because they're not able to bring it up. On the other side of things, if the VPD is high, what we find is we've got either a low humidity or a high temperature, or maybe both. And on the plants, the stomata will be closed to avoid wilting, and that means that they're not being able to absorb the CO2, and you'll get slow growth. And what you'll end up with is stunted plants and most likely wilting. With the VPD, there's like a region where it's optimal for plants. For most plants, the optimal VPD is around about 0.8, 0.9 kilopascals, but there is a range from about 0.5 up to around about 1.2, and you can see it in this graph here in that green range. As you get into the yellow section, you're sort of on the cusp, and the plants aren't going to be happy, and in the red zone, you really need to try and do something about it. And so, what sort of things can we do to affect the VPD? It's not possible to directly modify the VPD values, but we can indirectly doing it. So if the VPD is low and the humidity, say, is quite high, what we can do is ventilate. So force the air up through the vents, turn the fans on, and do an air exchange. To try and get the other thing we can do is heat the air, perhaps get it rising so we can push it out the vents. And if you're in a place where the humidity is already quite high, we can dehumidify. If the VPD is high, so the temperature is quite high, the humidity is too low, we can reduce the ventilation. So close the vents, maybe don't run the fans. Let the plant's own transpiration push the humidity up and cool the greenhouse down a little bit. And the other thing we can do is directly increase the humidity through humidification. That could be via a high pressure fogging system or through a misting.
Yeah, and it's important. So when we're talking about VPD and advanced controls, I mean, obviously you can, if you just had a thermostat and a humidistat and you were just trying to control fans, that way you wouldn't be able to have this type of control that you need. It's important to also be data logging all of your VPDs so that when you're talking to your agronomists, your consultants, the grower, you can see, you know, I don't know why my plants have been slowing down growth this week. You look back at the VPD over a few days, you realize that you're in those yellow zones, and then you actually want to start making some changes. So, you know, we want to run heat to bring the low VPD up a bit. We want to bring that VPD up higher, but we also don't want to be opening up the fans at the same time, because running the heater while the fans are on and pushing air out of the greenhouse is a huge waste of energy. So we want to be using the type of control that can keep in mind that every component that we're activating, when it's being activated, and the most efficient way to use it. So CO2. So CO2 in greenhouses. This is a topic that a lot of people bring up. Like I mentioned earlier, some people just don't know why you would use CO2 in greenhouses. Other people wouldn't ever grow in a greenhouse without their CO2 supplemented. But before we get there, like, why is CO2 important? So CO2 is required for photosynthesis to occur. Photosynthesis is, very simply put, the act of turning light into energy so that the plant can grow. When you have a higher level of CO2, it can increase your sugar uptake. Anytime that you increase your sugars, that's more carbohydrates, it'll increase the growth rate of the plant. It'll also, for fruiting plants, you're going to have a much sweeter plant if you can get a higher sugar uptake with heavier yields. CO2 will also kick in earlier flowering, higher yields, and improved stem strength. A really good example of this is tomatoes. So with a tomato, you sell that tomato based on weight. And so you want them to be as heavy as they can be. You also want them to be very flavorful and sweet so that people want to keep buying your tomatoes. You want them to flower early, because the earlier the tomato plant flowers, the more tomatoes you get. You want higher yields, and the heavier the tomato is, you need the stems to be stronger so that they don't fall off, of course. And so it's the CO2 for fruiting and flowering plants is almost a necessity. But keep in mind that CO2 is not necessary at night.
Yeah, so it's important to note that if the plants aren't photosynthesizing, they're not going to do anything with the CO2. So if you've got a control system where the CO2 injection doesn't know anything about the daylight, whether it's whether it's day or night, then you could be essentially wasting a lot of that CO2 and a lot of the energy you're using to generate it.
Yeah, and so with CO2, one of the questions that people will have is, well, how much CO2 do I need? They want to try and figure out how much are they going to go through, how expensive is it going to be. Some basics: CO2 ambient across the world is usually around 350 to 400 parts per million. It's going to be higher, of course, if you're in cities. It's going to be lower if you are out in the middle of the country. But right around that 350 to 400 mark is kind of an average that we plan on. And as you can tell by just looking outside, plants are usually perfectly fine growing at that. The challenge in a greenhouse is that we are trying to steer these crops to grow much faster and to produce a lot heavier than they are when they just grow wild outside. So we want to make sure that as the plants are getting a ton of sunlight throughout the afternoon and they're photosynthesizing a lot, transpiring, that we want to make sure that their CO2 isn't going too low. And so if you're not injecting CO2 or you're not adding CO2 to the greenhouse, you could fall dangerously below that 300 parts per million mark. And just like a human without oxygen, a plant without CO2 will become extremely stressed. And stressed plants will give you all kinds of problems. So what a lot of people doing research have found is that at about 1,000 parts per million, they get about a 30% increase in yield for most crops. 30% is huge. We also have growers that push it 1,500, 16, 17, 1,800 parts per million. And they kind of find that sweet spot with a specific plant that they're growing and the varietal of that plant, and trying to decide exactly how much CO2 will get them the effect that they need and still stay cost efficient. The type of growers that usually benefit from CO2 addition are your fruiting plants like your tomatoes, like we discussed, because you've got a plant that you need to kick into flowering. Once it's flowering, we want it to start setting fruit, and then we want that fruit to be big, tasty, heavy. We want to increase our yields. And also just flowering plants. So flowering plants, you need more flowering sites. You want denser flower sets, and you just want it to be a bit heavier. So with all these benefits of CO2, why wouldn't everybody use it? The first, and the one that I always get heard first, is it's expensive. You have to install a whole CO2 injection system into your greenhouse. You've got to keep up, you've got to maintain the CO2 system, and can you justify the expense? That's one of the first reasons that growers will say that they don't use CO2.
The other types of reasons that you might not use CO2 is infrastructure. If you've got an older greenhouse where where the joints don't fit cleanly and you've got a lot of leaks, any little bit of wind running past the greenhouse will suck the CO2 straight out those leaks. So you need to make sure you've got a greenhouse that isn't going to leak all that CO2 out, so you're not just wasting the energy creating it. Another aspect to why you might not use CO2 is the simplistic control system you've got. So if you've got a control system that doesn't differentiate between day and night, whether the light, the sun is up or the lights are on, and it's still injecting CO2, that, again, it's a lot of wasted money, and it may pay to invest in a more advanced control system that can manage those aspects more closely.
Yeah, and so for a lot of growers, when you're kind of in the beginning setups or you're designing your greenhouse, I mean, it's important to keep these things in mind. But I usually recommend that people will at least monitor their CO2, even if they're not quite ready to control it, and make sure that you're not having those huge dips in the middle of a hot afternoon. Make sure that the air exchanges are actually bringing in enough CO2, because just because we think that the air exchanges are bringing in the proper amounts of CO2 does not mean that they actually are. So even if you're not quite ready to start injecting CO2, I would still recommend that you get a nice quality CO2 monitor so you know what's happening. Once you're now if you've decided to do CO2, there's a couple different methods for getting CO2 into the greenhouse. As we talked about, of course, there's the fans. That's a fairly passive way to add CO2 to the greenhouse. It's just pulling air from outside. To actually supplement the CO2, a real popular way to do this is by burning propane. So in colder climates, when you need to actually heat your greenhouse, if you run a propane heater, the byproduct of burning propane is CO2. So you actually can kill two birds with one stone there. You get heat for the greenhouse and you get CO2 for the plants. So that's a really easy way to get CO2 into the greenhouse. The opposite, if you're in a warm climate and you don't want to be running heaters because you don't want to have to manage the extra heat, then you actually just get CO2 in tanks. So you can have small tanks that you can move around throughout the greenhouse, or you have a very large tank that the local gas company, fills for you. And you will have injections or solenoids that would be, clicked on and off to inject the CO2 directly into the greenhouse. One of the things that you don't want to do with CO2 is just kind of blow it at the top of the greenhouse and hope that the plants get it. That's super inefficient and mostly a waste. So if you can see in this picture on the right side on the bottom, it's actually just a piece of plastic tubing that runs along the base of the plants. It has a bunch of little tiny pinholes poked into it. And the CO2 is injected directly into that tubing so that the CO2 is right where the plants are. And for some greenhouses, these can be moved as the plants get larger, but it's making sure that we're not just putting CO2 into a greenhouse and then extracting it out, but that we're actually getting it right to where the plants can utilize it.
Yeah, and if you are in a place where you don't want the side effect of the heat from burning the propane or running the system, what a lot of high-tech greenhouses do is they utilize the boiler. So they'll run the boiler during the day to generate a lot of heat, but they'll pump that heat into a hot water storage system, and by using the byproduct of running that boiler, they can separate the CO2 and pump that into the greenhouse when it's needed. And at night time, they'll take that hot water that they've generated during the day, and then they can use that to run through their hydronic heating and heat the greenhouse. That's a really expensive option, but if you've got a high-tech greenhouse and you're at the design stages, it's really something you should consider, because the benefits of doing CO2 injection are really astronomical.
Yeah, so now that we've talked CO2, I want to kind of lead into supplemental lighting. So for a lot of growers and greenhouses, we use we need to add additional lighting. We can't just depend on the sunlight being enough to get the crops to perform like we want. So all crops, of course, depend on light for photosynthesis. So we need to make sure that we're giving the crop the amount of light that it needs to act the way that we want it to act. As all of these settings are interconnected. So we discussed CO2 a minute ago, and if you increase the light levels in the greenhouse, but you don't increase the CO2, you can have negative results. It's important to know that they're all intermixed, and so we'll keep talking about how supplemental lighting, CO2, blackout curtains, how they all work together.
Yeah, and one of the things you'll hear a lot of once you start talking about supplemental lighting is the daily light integral. The scientific sort of description is that it describes the number of photosynthetically active photons delivered to a specific area over a 24-hour period. But essentially, what that means is how much light has the plant got and over amount of time. There are two different types of measurements that we do, so there's a little bit of confusion about which one that we do. So what we have is different spectrums of light, and the PAR, which is the photosynthetic active radiation spectrum, which goes from 400 to 700 nanometers. That's the spectrum of light that the plants use to actually photosynthesize, and that's what's used in the measure of the daily light integral. It'll count up the number of photons within that spectrum and give you like a total at the end of the day. The other type of measurement is the pyrometric. That includes a little bit of the infrared spectrum, which helps drive transpiration. So if you're looking for the rate to irrigate a plant, you want to use the pyrometric measurement. But if you're trying to figure out, or you're trying to define the amount of growth you're going to get, you're going to want to use the PAR, and that will give you the daily light integral. And different crops, they'll need different daily light integrals to give you the growth that you need. So there are different. Oh, sorry, Karen.
Well, there's different ways to manage your light levels in supplemental lighting, data extension, solar top-up. So I'm going to let Kevin talk a little bit about those.
So the first thing that you want to do is, with supplemental lighting, one of the things you might want to do is day length extension. So this is basically adding more light to increase the day length. So with this method, we're trying to fool the crop into thinking that we're in a longer day period, so we're in a summer cycle, and you'll be able to get the flowers to set a little earlier or later, and you're manipulating the seasons. The other method for use of supplemental lighting is a top-up. So when you've got a specific daily light integral that you're trying to maintain, if you haven't had enough light from the sunlight through the day, you might want to run your lights for a few hours at night to make sure you reach that daily light integral and get the growth that you need. So what the systems will do, an advanced system will count the number of photons that have hit the light sensor, give you an accumulated total at the end of the day, and calculate how much longer it needs to run the lights in order to achieve your daily light integral and get the results that you want.
Yeah, and I mean, just the power savings alone by only running the lights when you actually need lighting. So many growers that, they just say, okay, the sun goes down at 5 p.m., I want my lights to go till 9, and they just run it for 4 hours without actually having the idea, are the plants still utilizing the light at that point? Is it too much light? Is it even enough light? So having these advanced controls is the most efficient way to run your lighting, which, as I mentioned earlier, is one of the most expensive aspects of doing a full total greenhouse control, is running those lights. The energy expense is off the charts. I just wanted to mention two little side note, guys. I forgot to mention at the beginning. If you have any questions, please go ahead and put those into the panel on the right. I see a few people are popping up right now. We're going to be answering those at the end. So just populate as you think of them. Now we're going to get into blackout curtains. So why would you want to use a blackout curtain? The main reason that you want to black out all of the light from the plants is that you want to steer the plants to a certain growth stage. So as Kevin just mentioned in the previous slide where we were talking about wanting to extend the day length to try and trick the plant into thinking that it's summertime, we may want to trick the plant into believing that it's harvest time and that it's, fall, and that plant needs to start, doing its fruiting and flowering and getting it ready to harvest. So there's extending days and shortening days. You want to have full control over your light cycles. So depending on what you're growing, being able to steer the plant to perform the way that you want it to perform at different times of the year is going to be really important. And we have to remember that plants do like a rest period. So plants work really hard throughout the day to grow. So they're photosynthesizing, they're transpiring, there's a lot going on with a plant. They actually do need a rest period just like we do. You need to sleep and rest everything so that you can wake up and do it all again tomorrow.
Yeah, so if you're looking at the image on the slide here, you'll see the blackout curtains, so the black thick bars in the middle. It's a bit hard to take a photo of blackout curtains when they're fully extended because it's just black. But what we see with the poinsettias here is a poinsettia is a long night plant. It needs more than 12 hours of darkness for the flowers to set. So in the southern hemisphere down here in our holiday season, we want to get poinsettias around about this time of the year, but our days are getting longer and longer, and so you need to manipulate the night period so that the flowers will set and they'll be ready for us to harvest and get into the shops ready for the holiday season.
Yes, and so another crop that a lot of people use blackout curtains for is cannabis, of course. So it's very important that we can alter the day length to steer the plants. So for cannabis, a 12-hour day length with a 12-hour night during flowering is extremely important. It's the way that you're going to get the heaviest flower sets that are buds, and you're going to be able to get the most out of your plant, the highest yields. The cannabis plant can be very sensitive when it comes to outside light. So what will happen is, even in a greenhouse, we want to use all the free sunlight that we can all day, right? That's free sunlight. We want to take advantage of it. But on a long day in the middle of the summer, we need to fake it and tell the crop that no, it's only been a 12-hour day. So we have to pull blackout curtains over the crop. If the crop gets too much light during a flowering period, it can either revert back to a vegetative period, which can create all kinds of genetic problems, and the leaves will curl funny, and the buds will get really loose, or it can actually kick the plant into seeding. So a plant that's been exposed to light during its night period can become stressed. When a plant becomes stressed, it wants to seed and reproduce because it thinks that it's about to die. And so we definitely don't want seeds in a cannabis plant that can actually ruin the product. The other aspect of it is increasing your number of harvests. So if you're growing your cannabis outdoors in the sun, you usually get one harvest a year. You start in spring, you harvest in fall, but for a lot of growers, they want 3 or 4 harvests per year. So they have to actually steer the plant growth and be able to lengthen days by adding supplemental lighting and shortening days by using blackout curtains to be able to get those multiple harvests in 1 year.
Yeah, and the one of the things that people don't realize is that manipulating the light period, the photo period for the plants, is actually used more often than you think. If you have, say, flowers for holidays, say Easter lilies, or plants for, roses for Mother's Day, you need to be able to get those flowers set and deliverable on that day, or you've missed your whole market. And so manipulating the lights or the blackouts to get the flowers or the crop ready is really important in a lot of instances.
Yeah, you missed that one day, and you've missed the entire year. Their Mother's Day only comes around once. So now we're going to touch on root zones.
Yeah, root zones is an area that's easily forgotten. For us humans, the air temperature and the humidity, we directly feel that, but we don't have roots that go into the ground, so it's easily forgotten. And managing the root zone, getting some advanced controls in there, is actually one of the things you can do even if you have a reasonably low-tech greenhouse. So if you've got a tunnel house with open sides or mesh walls, if you can manage the root zone, you can actually get some more advanced controls and more impact on the plants. So what sort of things would you be measuring for root zone? The first thing you probably want to do if you're growing in a media, say cocoa peat, coir, or rockwool, is to measure the runoff, knowing the amount of water that's coming out from the root zone compared to what you've put in, knowing what the EC measurement is going in and coming out, the pH levels. All of that is really, really important, and lets you understand the roots, the plant's comfort level, and steer them towards early fruit set. All sorts of controls can happen when you start monitoring that root zone area.
The other thing that you can monitor that a lot of growers they count on this, is monitoring the moisture levels in your media. So whether you're in soil, you're in cocoa, rock wool, the media is where all of your water is. And rather than watering just based on a time of day, so rather than just saying I want to water every 2 hours, we actually want to water when the plants need it. So especially in a greenhouse where we can't control what the sun and the weather outside are doing. So we'll have some mornings where it's a little bit more overcast than others. We'll have some days where it's super bright and warm out. The plants will be transpiring at different rates, which means that their media is drying out at different rates. And so we want to be able to trigger irrigations based off of moisture levels, not just time of day. The other is also monitoring the temperature of the water in the system that you are using. This is especially important in hydroponics. So in NFT, DWC, or deep water culture, raft systems, it's important to make sure that water isn't getting too warm. So with warm water, pathogens build up really easily, and the warmer the water, the less oxygen that there is available to the roots of the plant, and the plant roots need a lot of oxygen. So it's important for monitoring that.
Yeah, and one of the things you want to note is if you are running an EFT system, it's important to measure the temperature at the end of the run rather than at the start of the run, because as it's running down the lines, the water is going to heat up, and what you'll end up is with a bounty crop at one end and a suffering crop at the other, because the oxygen's reduced due to the temperature increase as it runs down. Now, the root zone management is a huge topic, and we probably spend another webinar talking about just that in the future. But in the scope of the advanced overview that we're doing right now, this is where we're going to stop.
Yeah, I mean, for the advanced control, I mean, just simply like for the monitoring of the temperature, if the water is getting too warm and our oxygen levels are getting too low, we can activate chillers to bring that water down, or to bring the temperature down of the water to increase oxygen levels. So we'll talk a whole lot more about this down the road. But yeah, I just wanted to kind of mention how these advanced controls can really work. So we're going to wrap it up. With any advanced control system that you're looking at, just make sure that you have remote access capabilities, you have data logging capabilities, that you have the ability to get text and email alerts and alarms if something goes wrong. With a greenhouse that has this level of control, you need to know immediately if something hasn't worked like the system thinks it should. So if it thinks it's injecting CO2 and your CO2 levels are not increasing, if it thinks that your lights should have turned on and the light levels are too low, you want to know immediately so that you can go in and you can fix whatever has gone wrong. As well as the data logging for consultants, you know, that you're working with, to be able to understand what's been happening in the greenhouse, what yields you've been getting, and what changes you can make to increase those.
Yeah, and it's important to also work with a control system that can understand and work with these advanced greenhouse controls. So you won't get any benefit if, say, you've got disparate control systems that don't talk to each other. Say you've got a CO2 injector that's running and it doesn't realize the lights are off, or it's nighttime. That type of thing is detrimental to your wallet and also can affect the crop. So it's really important to make sure you've got one of these control systems that can give you those alerts and combine all those specialized features all in one package.
Yeah, so, you know, we really appreciate you guys joining us today. Please, you know, we're going to start answering questions in just a minute here. But we did want to let you know we're going to take a little bit of a break for the holidays, but we're going to be back in February, and we're going to bring this conversation indoors. I'm excited about that. So we're going to be talking about grow room controls. So the first one will be an introduction. We'll be talking temperature, humidity, lighting, and CO2. Keep an eye out for emails and, you know, Facebook posts and things from us about that, and make sure to sign up for our next webinar. If you would like to get in touch with us, please feel free to go to offer.autogrow.com and you can fill out our contact form, and we will get you in touch with the right expert for your project. If you want to reach out to me directly, I'm here in the States. You can just get me at kelly@autogrow.com. Kevin is down in New Zealand, so we'll go ahead and I'll go ahead and filter those for him. Yeah, so let's see what type of greenhouse controls or what type of questions you guys have about greenhouse controls.
So the first question we've got is from Jeremy, and he's asked to briefly describe what PAR and PYRA are. So those are just two different spectrums of light that the plants are used to photosynthesize and drive transpiration. As I said in the earlier slide, PAR stands for photosynthetic active radiation, and that's the light photons that fall within the 400 to 700 nanometer spectra. The other type of measurement that the pyranometers measure includes the infrared, which is the light wavelengths that are above the 700 nanometer range, and the infrared drives a lot of that transpiration. It's heating the plants up, and they're really it's driving it. So what we typically use is we use the pyranometric measurement to trigger irrigations, make sure that the plants are getting the water they need to feed the transpiration rate, and we use PAR as a measure of how much growth you should have got. And that's why the daylight interval is measured in PAR, because we're trying to ensure that we're getting the right amount of crop growth so that we can deliver consistent yields on time.
Yeah, and then we have one here. Hi, Harley. It's been a while. I hope all is well. He asks, does Autogrow control nutrient temperature or substrate temperature? If so, how? So we monitor the temperature of your nutrient stock of your nutrient solution, so your reservoir, and we can activate heaters and chillers to either warm it up or cool it down. We can monitor the temperature of the substrate, but I don't think that we have a way other than cooling the water itself down or cooling the environment down. Can you think of a way, Kevin?
No, so what you'd have to do is just chill the water that's being fed to the plants. It's not done very often, generally because of the volume of water that you're feeding out, and it's not recirculating. So you're cooling it once and then feeding it out. But monitoring the temperature, one of the things you could do is water a little bit more often if the temperature's getting up a little higher. But generally, the substrate temperature is not something that we're trying to control. It's just something that we're monitoring.
Yeah, absolutely. And in a recirculating system, the heaters and the chillers make more sense because you're reusing the water over and over again. Well, like Kevin said, it doesn't make a lot of sense to run an expensive chiller for a drain to waste system. But it is good to always monitor it. The more information you have, the better decisions you can make about the type of control that you want.
Yeah, and one of the things you could do is put your water tanks underground so they've got a more stable temperature profile. If you put them up in the above ground and you're in a really hot environment, there's lots of sun, that water is going to get heated up. But if you put it underground, which is I know really expensive, but if temperature is an issue for you, then that's one of the things you can do is sort of get it out of the sunlight, put it into that stable temperature source.
And Kevin, do you want to take the low-tech tunnels one?
So so Bao has asked the question: plastic low-tech tunnels. How do you know what extent of control can you accept, or what control can be achievable with your structure? That's a little bit difficult to answer, but generally what we've found is that if you've got some level of automation, so you've got wind-up walls or vents that can open and close, then you can actually get really good automation and temperature and humidity control with relatively low investment. You know, just adding some motors to those vents. You can save on labor, having people walk around to open and close them. You can save on the crop. You can get better yields because it's more consistent. No longer does the person walk around 12 greenhouses winding the vents open and then winding them closed again. So what we found is that with those low-tech greenhouses, you can actually get a lot of benefits from just some real simple things. Even with the low-tech tunnel with open ends, we've found some growers who've just put in some air circulation fans and running those when the temperature gets a little higher, the humidity is getting a little bit lower. That's increased the transpiration rate and given them benefits that they hadn't been able to achieve before.
And yeah, the copy, so go ahead, you've already signed up for the webinar. You will be getting an email from us thanking you for attending. Make sure if you want to get a copy of the previous webinars, why don't you just go ahead and reply to that email and let us know, and then we'll get those over to you.
I think the previous webinar has been uploaded to YouTube, so if you look on our channel, you'll be able to find it there.
Yeah, for sure. Let's see, just looking through here. Now, the idea of the ROI on these robust control systems, it's really difficult, and I would be more than happy to sit with you and actually go over the product. This is for Jeremy. Jeremy. He says that he's an architect working on a large cannabis cultivation facility. Probably the easiest way for us to discuss ROI on that is for you and I to sit down and actually just talk about what exactly it is that you're looking at managing. For a lot of these advanced control systems, there's added benefits. So a lot of people see advanced control as, oh, it's just a labor saver. Well, it is a labor saver, and that's huge. And that's one bit of ROI that you can talk about. But the other is just your risk management. And that's something that I think that a lot of people kind of overlook when they look at automation, that automation truly is risk management. If your timers or sensors are to fail, your whole system will go down and you can have complete crop loss. And when we're talking about a product like cannabis, we could be talking millions and millions of dollars lost in a greenhouse just by an environment sensor going down or by the lights not turning on when they're supposed to. So there's some risk management to it that's really hard to put an actual dollar amount on until we start talking about the specific system. But if you kind of look at, what would one crop loss be? What would an entirely, a ready to harvest greenhouse, if that went down, what would I lose? It's the risk management that we look at a lot. But I would be more than happy if you want to reach out, Jeremy. We'll discuss your project specifically. We'll talk costs and kind of how we can figure out that ROI.
So Harley's asked another question. Should daily light integral be taken into account in addition to temperature difference? So I think there is an interrelation between those two. With the temperature difference, I'm guessing you're trying to talk about the 24-hour temperature integration. So what plants are really interested in is the overall 24-hour average rather than an instantaneous temperature. And so what you can do with the supplemental lighting and the blackout curtains is you can manage the daily light integral outside of those periods where the temperature is excessively hot, and you can take a lot of additional controls and try and manage it outside those periods where you're getting too much sun or pull shade costs across. There are a lot of different ways we can manage temperature as well as the daily light integral.
Yeah, and I'm looking at this, and I will say here to Badra, yes, we will go ahead and get you over the previous webinar links. That's not a problem at all. And Talbert, we haven't actually had that question before, but I'm interested in that. Maybe we do a webinar that's not as much of a webinar about general, but maybe we do like an introduction to our software. That could be kind of interesting. I'll definitely keep that in mind. Okay, well, I think that we are good to go. We've answered all of your questions. We are looking forward, please, like I said, offer.autogrow.com or kelly@autogrow.com. Either way to get a hold of us. And yeah, we look forward to talking to you guys soon. Keep an eye out for the next webinar.
Thank you for attending.
Yep, thanks. Have a good afternoon, everybody. Bye-bye.
Bye.